My name is Steve Bjork. I'm the author of Lambda Shop and CTO at MindTouch. We are a downtown San Diego company. Although right now we're all working from home, so our office is in downtown San Diego, neglected, abandoned. Regardless, so what I'm going to cover today is how to write services that can be composed together. There's a variety of techniques. Ask any questions you have on the chat, and then Patty will raise them during my walkthrough presentation. If they're contextual relevant, otherwise at the end, I figured I'd leave some time and we can have a conversation that won't be recorded, so it can be a lot more free-flowing. So without further ado, let's talk about service composition. This is a really critical part of building reusable components that we can build our software on. So I'm going to cover just some fundamental basics, what I think are the most useful, common serverless building blocks that I've been using over the last few years. These are the ones that are probably most relevant for familiarizing yourself with. Then just how resources are encapsulated. So how do you keep them away from other services? How do you make them available? A very common pattern I found to be very effective is called Cqrs, Command Query Responsibility Separation. That's actually a different word for the S, it means the same thing. I'm just not comfortable with it, so I call it separation. And then how to compose pieces together. And then we'll actually do kind of like what we looked at, we'll do it in code, just so you have a sense of how these things are built in practice, as opposed to just seeing slides about it. So that's the lay of the land. I'm hoping this will take anywhere from 45 minutes to 60 minutes. Patty, make sure to interrupt if you feel we're maybe a time check around 20 minutes before the hour is up, so I can adjust accordingly. Great, so let's start talking about serverless. Probably mostly familiar with any of these, but you can broadly categorize the serverless building blocks into 4 different groups. Event sources are things that trigger functionality. This is where information communication occurs. And there's a lot of them. I pulled out these 4 just because they tend to be very common. The first one at the top is Event Bridge. That one is actually the newest entrant. It was called before Cloudwatch Events, so you'll find documentation under both terms. More recently, everything has been rebranded as Event Bridge, but Cloudwatch Events is the original term for it. That is a way of emitting something into what they call an event bus, and then you can define patterns when you want to be notified when such events have occurred. The other one, which preceded it and is very attractive as an alternative, and still to this, even though Event Bridge is newer, is SNS. And more often than not, SNS is used in conjunction with Cqrs. They're really two serverless services that work extremely well together. SNS stands for Simple Notification Service. You create a topic, and then you publish on the topic, and the topic can have any number of subscribers in the millions. So it's really fan out to a very large degree. And it can deliver the notifications that it receives across a whole bunch of different channels, such as email, HTTP endpoints, and of course, Lambda functions. As well as Cqrs, which happens to be one of the more popular subscribers to it, because Cqrs it's a great building block about reliability. Reliability is not something we want to talk so much about today. I think that deserves its own session. But just be said that SNS and Cqrs usually work together. And then API Gateway, of course, request response style patterns. These API gateways there's a few different incarnations of it: REST API, HTTP API, and now WebSocket. And they all have a little bit different properties, of course. What I've not listed here, it's a whole different category called streams. These are also very popular, and they also deserve their own consideration. They work quite different from the ones discussed here. On the compute side, I put in 2, but frankly, the reality is, other than playing with step functions, I've never ever only had use for lambdas so far. Not that step functions don't have the purpose, they just are much, much less common. So in the compute category, you really have one dominant building block. That's of course Lambda function, which enable the end-to-end serverless story, which is so compelling. Then lastly, on this kind of an active component is our storage services. Again, there's a Amazon offers a wide plethora of possible storage solutions, but the two that are really predominant is the simple storage service, S3, S3 buckets, which have been around. That's either the first or second service that Amazon ever launched. And then much later, DynamoDB, which is a very fast lookup table with certain properties on which a lot of relational models can be mapped to. Take some effort. And again, DynamoDB is something we'll touch a little bit on today. However, it's going to be really deserving of its own session just because of how it works. Lastly, the two honorary mentions I wanted to make are Cloudwatch, specifically Cloudwatch logs, but there's also metrics, alerts. This is how you keep an eye on your services. Logs are incredibly useful for debugging, but the other ones are also very useful for knowing when things are not working the way you expect. And lastly, and most importantly, actually, is CloudFormation, which is the infrastructure as code. So there's different ways you can build your applications with AWS. And if you find online tutorials, they very often will walk you through steps that you can take in the AWS console. And that's great for learning, for playing around with things, but it makes it hard, of course, to reliably create it again or ship a new version of it. It's not the way to go. So instead, CloudFormation has a template language, can either be JSON or YAML, and that's what Lambda Sharp built upon, and allows you to describe the services in such a way that they can be instantiated as often as you like, wherever you need them. So that's a fundamental critical building block. None of these services here have any kind of instances associated with them where you have to provision ahead of time. They all have models for pay as you go. There are options for some, like DynamoDB, that you can actually provision additional capacity instead of it being elastic, but fundamentally you don't have to. So if you don't use them, you don't really pay for them. Great. So that's kind of the landscape. These, I think, are the key Amazon services to familiarize yourself with. Step functions being the last one on the list, just because it's not that common. Still a very interesting service, just not common. Okay, so as I mentioned, CloudFormation is the way of kind of describing groups of resources that work together. The terminology for CloudFormation is a CloudFormation template, is the part you write. And then when you upload it to the CloudFormation service and instantiate it, becomes a stack. Where the term came from, I don't know, everybody knows. But CloudFormation stacks is what you can look at in your CloudFormation console, and they contain all the resources you created. Resources, not unlike object-oriented modeling or even functional modeling, are really fall into two categories: those that are private to the stack and those that are public, meaning other stacks can access them. And so this form of encapsulation is really the building block for composing things together. Unless you make a resource publicly available, another stack cannot import it and take a dependency on it. Now, you can always hard code the name of the instantiated table or topic. Just don't do that. It's a really bad idea for a variety of reasons. So let's not go there. Okay. And then in terms of organizing the stacks, the functionality of it, a pattern that I've gravitated towards and I'm very fond of is Cqrs. So what is fundamental about this pattern is that you distinguish between the routes where you send commands to mutate state and routes where you query information. Traditionally, often these routes are kind of like merged into a single interface. This one, Cqrs fundamentally says, let's separate them into two different interfaces. Almost like if you had a read-only interface, allows you just to do read operations. And often have different models behind it and so on and so forth. With stacks, we can actually take it a step further. And the command aspect can be a topic, can be an API gateway. It's some kind of interface, of course, where we can send to the service an instruction to do something on our behalf. However, the outcome of it, where we can query and see, fetch results or look up state, for example, commands might be add an item to a list. And the query is give me all the items in the list. Now, if the consumers of your service are inside your Amazon account, So, we're not talking about having a public interface. It is actually my recommendation that the consumer should go straight against your data store. So earlier we talked about S3 and DynamoDB. And the reason is, but it could also be an Aurora database and so on. And the reason is doesn't matter if it's a serverless service or it's an instantiated storage service, the database providers are often some of the most reliable software ever written. I mean, these things are just incredibly rock solid. And so they have many nines of reliability when you use them. Putting any of your own code in front of it is only going to reduce reliability, period. It's very simple. Now, this approach requires some discipline because AWS, at least currently, does not offer a mechanism by which a stack can make resources available and then say, hey, but you can only do read operations, you can't do write operations. Unfortunately, anybody who takes on the dependency, they could say, oh yeah, I'll write to your store. Obviously, don't do that, but unfortunately, there's no way of enforcing it right now. So discipline needs to be applied instead. And then you can have many consumers just going straight against the store. You don't, and you can think of the store that is made available as being your publishing endpoint for queryable state, be it single items, S3 can be pretty good for that, or be it more relational models. DynamoDB is excellent for that. And DynamoDB more recently, I think the last 2 years, has added transactions. So it's actually possible to publish multiple rows simultaneously if that is required, since ultimately you need a consistent query model to achieve it. If you can get a consistent query model in place, you don't have much of a choice. You're going to have to put some code in front of it. Just be aware that aside from latency increase, obviously, you also have decreased the reliability because you have introduced your own code, which has its own failure cases that were not there before. So Cqrs, basically, you think about a place where you take commands, can be a queue, can be an API gateway, and then you think a place where others can go and fetch the state. And if your business logic doesn't have to be around for doing that, that is a huge, huge win in reliability. So that's kind of like the pattern that we're also going to be using here. Now, the next thing is how do you share resources? We talked a little bit about it. So again, a stack, private resources, public resources. The way you can access them is we have that's two mechanisms that are readily available. The first one, which is very common and is seems to be the most common one used, but actually the one that Lambda Shark favors the least, is nested stacks. So here you kind of like you play Russian dolls. So your stack has other stacks inside of it that may have resources, and then it might be built like enough stacks, and you just totals all the way down until you have a stack that has no nested stacks. Just like before, stacks make certain things available to the outside world, then these can be consumed by the parent stack and relied upon. The reason I'm not a huge fan of nested stacks, our Blazor implementation uses it to great effect, but in general, I tend to shy away. Update semantics are a little bit nebulous in terms of understanding how nested stacks update with parent stacks. And understanding update semantics is critically important because that's ultimately, shipping a new version of your code. And nested stacks just make it a little bit more opaque and harder to track. So that's one. The other one is, by definition, they only belong to the parent stack. So if it's a piece of functionality that is being added to the parent stack, it will be duplicated in every single parent stack that needs it. Sometimes that's the right patterns, but many times I found it not to be the optimal pattern. It's actually nicer when you can think of your own CloudFormation stack that you deploy as being new services that your other services can depend on. And that's side-by-side composition. So this is when you launch one stack, it provides certain resources, certain capabilities, and then you launch another stack that imports these resources so it can interact with them. And so you chain things together. And now you can update any part of this environment as needed. I should point out that you cannot update a nested stack without updating the parent stack. The only way you get to ship new functionality in a nested stack or bug fix is by fundamentally, you send an update to the parent stack, and then the parent stack triggers an update on the nested stack. With side-by-side stacks, You can share resources. You can just provide some more powerful functionality that cross-connects things. So it has a lot of very nice design properties, but it's not isolated, which means breaking changes and things like that, so you'd be super careful with. The other one is what happens if you take the stack that provided the resource away and then the stack that depended on it breaks. Well, fortunately, there's some mechanisms, and we'll talk a little bit about those. So the mechanism by which side-by-side composition is fundamentally achieved in Lambda Sharp, again, you could do this by copy-pasting values that one stack provides and then just put the other, or using a parameter store or something of that sort. However, what I advocate is this function called import value. It's a CloudFormation function, and it allows you to specify the name of an exported value from another stack. It has a few interesting properties, which are really, really compelling. One is every time a stack uses import value to get a shared resource from another stack, so only things that you said you wanted to share will be made available for exporting. That's kind of the public-private separation. Every time a stack uses import value to resolve an export from another stack, it is tracked by CloudFormation. You can actually see all the exports that a stack has and all the stacks that depend on it, that have consumed it. That, in addition, aside from providing a nice dependency tree, also adds termination protection. So in the previous example, the left stack is exposing a resource at the bottom that the side-by-side composition stack, the sibling stack, is consuming. If that is done over import value, you can actually not delete the left stack. CloudFormation will not allow it. You will see that, oh, gee, one of the exported values is still being consumed. You can delete it. So you don't break things. You don't get that protection if you pass the information along as a simple input parameter from the parameter store or to some other means. But if you use import value, you are protected. So it's incredibly valuable property of that mechanism. It comes also with, unfortunately, a little bit of a gotcha. Once you have imported a value, the stack that exported it cannot modify it, period. And it makes sense. If the stack that was exporting the value were, for example, to recreate a new resource, a new topic or something, and it changes the nature of it, well, anybody who imported it, it will no longer be the correct value. So the import value mechanism locks down what it is. And again, if a stack update tries to modify it, that update will cancel and be rolled back. It's not allowed. You cannot modify it, which means do not use import value for things you expect to change, like maybe passwords or settings, like how many nodes you want to run in a certain configuration. That's just not going to work. Now, the other thing is sometimes you do need to make those changes. Sometimes you want to these arrows create effectively a topology. It's a graph. You have stacks that provide resources and you have stacks that consume resources. And right now, if you just applied naively by importing values from an exported from a stack that exported them, you create a tightly coupled connection, and that connection cannot be severed, and the exporting stack cannot be removed. The only way to remove it or modify the value, let's say it is indeed a new topic value that you want to create. Maybe you changed something and the topic needed to be recreated. There was no way around it. The only way to get there is to delete all the dependent stacks. Well, dependent stacks could have their own export, could have dependent stacks, and so you have a cascading effect. So that's a really bad situation. However, CloudFormation actually provides us the mechanisms we need to deal with this situation. CloudFormation allows us to do conditional expressions. And so Lambda Sharp, whenever you do an import, it will, unless you override it, it will default to using import value from the stack that you specify and create this traceable connection, this dependency. However, if the need be, you can override the default value and it can either connect to a different stack, again, using a topic, maybe you're creating a new stack side by side, you want to redirect this dependency to the new stack, or maybe you even just created the topic by hand and the AWS console, and you take the ARN and you just put it in place of this input parameter that by default indicates to import from the original source, to just use this instead. So this allows you to break these dependency relationships with any stacks that use the Lambda Sharp import mechanism. just included for free. And frankly, you would not want to have to run it by hand. It's a little bit of tedious how it is built, and we won't go into the mechanics of it. But the key point being is that you can get the benefit of import value and the tracking of dependencies while still maintaining the flexibility of changing your dependency topology when the need arises. Again, super important to give DevOps the tools they need so they can act when it's required and not go through a whole CI/CD pipeline to change a template and publish it differently. Lots of flexibility there. Excellent. So maybe before I dive into the application, let me go just back one slide. Is there anything so far question-wise on what I've covered? I've covered quite a bit. If not, I shall proceed. All right. So I thought, so some of you have seen my previous presentation. You might be thinking I'm a huge Bitcoin fan. I'm not. However, because I did a Bitcoin Blazer app, now obviously Bitcoin here again. It has a really nice property though. The value of Bitcoin changes every minute. It's a nicer example than reading weather values, which tend to change more slowly. So it has that going for it, which I love. And so that's why I use it in a lot of my examples. Okay, so what we're going to be building today is effectively 3 different Lambda Sharp modules, which is the name for it's equivalent to a CloudFormation template, but with some additional syntax and capabilities, like I just said. The first one is going to be a simple Lambda function that is triggered on a 1-minute timer, and it reads from I think it's CoinDesk, but basically from a Bitcoin provider API, the current price. And if for currency, we grab it and then we publish it on an SMS topic that we created as part of our module. In addition, that topic is made available as a public resource by the stack. So other stacks can now discover it and subscribe to it. And that's exactly what our second module is going to do. Bitcoin table is all it's doing is it's listening to these notifications and then tracking the last 15 minutes worth of price updates. That gives us downstream and anybody the availability to fetch the most recent price at any given point in time. It's basically a storage solution with a little bit of history. And I just kept the history short just for practical reasons so that the table doesn't go indefinitely. So we put an expiration time in there. I'll explain a little bit how that works. But similarly to the first module, the second module table is also made publicly available. So no other services can subscribe to it and interact with it. Again, they should only do so in a read-only mode. And the last one is Bitcoin activity. Here we create a simple REST API endpoint where we can record some buy and sell activity. This Lambda function then reaches out to the imported table from the Bitcoin table module to fetch the most recent price and then store in its table, which is again shared so others can rely on it, the data in it. That a certain activity, a buy activity or sell activity has happened, the quantity, who was the user who triggered it, and what was the price at the time. So quite a bit of code. We'll build these modules kind of like more or less from scratch. We'll refer to some of the implementation, especially on the business logic. Just anything that deals with DynamoDB, doing it from memory, tends to be very error-prone and complicated. There are some easier ways of doing it. I'm not going into them today because I just wanted to stay close to the metal and not introduce too many abstractions at once. So that's what we are going to build. So let's get started. And okay, where is VS Code? Great. So pretty much all I have is an empty folder. So we're getting started from the ground up. The only thing I did in here is I did Git init, and that's it. So the next thing I'm going to do is add the Git Ignore file because it's going to get, I think that's avoided. Git Ignore. All right. Wonderful. Okay, so we said we're going to build 3 modules. The first one was the Bitcoin topic. So I'm going to make a folder for that. Bitcoin full screen. Bitcoin topic. And then I'm going to use the Lambda Sharp command, start with / new. And since we don't have anything, we know we're going to have to create a module. Module names have 2 components. One is the kind of like root namespace, and then the name of the module itself. So with namespace, I'm going to do set patterns, and then for the module itself, I'm just going to create an empty module file in our folder, and there's really nothing in here. So the next thing we know we need to add is a function, correct? So it's a function. Let's see, publish function. I like to append often at the end of my resource names what type of resource it is. I found that to be more convenient when working in CloudFormation afterwards and seeing just the name, seeing publish price function reminds me that's the function, because that's logs that be created. There's a whole bunch of other related resources that get created. So in this case, we want a function that is invoked on the schedule. So I'm going to select option 8. Oops. And that should create a new project here with our function. And it will also have added the definition in here. And I can take away some noise. We don't need this. We don't need description. I need a variable as well as a placeholder. Okay, so we have a function. Great. And the function pretty much contains nothing, but we should be able to build this at least. See if everything else is set up properly. And then have VS Code hopefully stop showing squigglies. Oh, haven't committed anything yet? No, let's commit. There we go. First commit is to ignore other things. Okay. Let's see. So where was I? Oh, yeah, function. Great. So that's the body of a function. So here we want to run the logic for querying the data, the Bitcoin API, and here any initialization we need. Well, the first thing is we want to be triggered once per minute. So we add a source. In this case, it's a schedule source, and this is what is it? Cloudwatch rule, what it used to be called. Now it's called, of course, event rule, and 1 minute. So this will invoke our Lambda function once per minute. The next thing we want to do is we need a topic to publish to. So we don't have that yet. So say /new resource name. I'm just going to call it topic. Keep it simple. Resource type. Let's see, how many topics do we have? Oh, a few. 3. SMS topic. Boom. Okay. When a resource gets embedded, it embeds automatically a link to the documentation. So it's usually a good way to get started. And then also all the expected fields, and then a little comment next to it if it's required. So these guys are only required when this guy is present. Descriptions, we don't have any. Tags, we don't have any. So in this case, we actually don't need anything. The only thing we need to do is to make sure that our function has access to the name of this topic. For that, there's a concept called scope, and we give it the name of the function. And this basically means this AWS resource is in scope of this function. And so now we can go here, because we're going to need it. Private string topic name. Yep, we're going to read our function settings. That's the name of the resource we want to read the name from. So Lambda Shop will automatically insert whatever the reference resolves to, which is usually an ARN for most, but not always. Okay, so the topic. Oh yeah, the next thing we need to do is, of course, add the package for using a simple notification service. This guy, store. Okie dokie. And so we need private by Amazon simple notification service. And I like to read my settings first, and then initialize clients. New Amazon simple. There we go. Okay, okay. Great. So now when we get invoked, which is once per minute, we do a read operation, and then, oops, we await SNS client, and I think it's publish. This thing. Oh, that reminds me, I still need to give us permission to publish that. And then we're going to have some payload here that we still, and that's just going to be actually what we fetch on the other request. So the thing that you need to remember is while you have the resource and you make sure that we can resolve it inside the function, we also need to make sure that we have permission to use it. And if memory serves, that's called SMS publish. That's the IAM permission that we need to give to our function so that we can call the publish function on it. So that should be in place. Okay. That should build just fine. And then what we need here is response. Await HTTP client, which is provided by the base class. HTTP client. Sync. Looks good. So now I'm just going to quickly go over the code here, which is published for everybody to enjoy afterwards as well. Publish Bitcoin function, and I'm just going to take, so I don't have to. This is reading the response, and then this is the URL. Okay. Actually, you know what we should do is probably let's put it in a log info, and then JSON. So this will write it to the CloudWatch logs. Oops. Well, so nicely remove this thing that I wanted. Await response content string. There we go. Okay. So if that's correct, we should be able to deploy it and confirm that it's working. So deploy will just do the same thing as we did earlier. It builds all the functions, it checks if anything has changed. If it doesn't, it skips it, packages up, checksums, things again. There's a lot of functionality around tracking changes that have happened to see if updates can be skipped. Of course, this is all brand new, so there's nothing to be skipped. We have to deploy it. And this will take shouldn't be taking too long. There's just a few things, and we can track its progress in our CloudFormation stack. So we should see it here. Hey, okay, good. And then we have our events coming in as things are being created. Let me make this a little bit bigger. And so now CloudFormation is instantiating the resources we asked it to create, which is of course the stack itself, called here Bitcoin topic, has a prefix which is based on the deployment tier called the demo, the name of the root namespace of the module, serverless patterns, and then the module name itself, Bitcoin topic. That's the default name a stack gets. It can be overwritten so that the same stack can be deployed multiple times. Then it's creating the topic. And the role that is used by the functions, it created the function itself, and then the subscription to the event. So all of that is happening down here. And that, as you can see, that takes a few seconds. Depending on how many resources are being created, a stack update can last, well, stack create tends to be slower, but a create can be as quick as 2 minutes, or it can also take much, much longer. More often than not, after the create or update is finished, the resources are usable, but there are exceptions. And those are just things to learn over time. One in particular, which is annoying as hell, is CloudFront in front of an S3 bucket takes an hour. Even though the update only takes 5 minutes, the create operation, for the security tokens to propagate, for one reason or another, it takes an hour. And apparently creating a scheduled event, event bridge rule, takes a minute. Okay, cool. So that's finished, that's created. So all these guys are done. Here we see the resources that have been created. So we only define the function itself, and the topic, but implicitly the scheduled event was created. There was a role was created as well, which has the permission, if we did it right, to publish to the SNS topic. We should be able to go to the SNS topic actually and create a subscription, and also see it coming in here. So I'm going to subscribe to it with my email address, sharp@gmail.com. Create subscription. That's going to send me a confirmation email that I need to accept. There we go. Yes, confirm subscription. So you can just spam people without them again. Good. You can go out of that again. And the timer triggers once per minute, so it may or may not have triggered yet. Let's see. Oh, it has. Fantastic. Okay. So we have, so these are the log groups. There's one log group per Lambda function. They get automatically created and cleaned up as part of the Lambda shard process. And then there's a stream for each instantiation of the Lambda. So Lambda instantiation can stick out for a long time. The first time is a cold start. Then after that is a warm start. They run much faster. If there's enough pressure, which would never happen here, it's a schedule, it's happening only once per minute. Multiple instances can exist simultaneously. If the Lambda doesn't get used for some period of time, which can range from anywhere to a minute to longer, the instance gets terminated automatically. You don't pay while things are sitting around in a warm state. You only pay while the instance is running. So looks like this is working. This is probably a little small in text. Let me zoom in, take that away. But you see here the function gets invoked. It started up. This was the first invocation. We fetched the payload from the CoinDesk service, and we then voted to this, but we also published it on the SNS topic, which means that if all goes well, I should be getting up. There we go. So we have the exact same payload here as well. So this is just happens to be using email. One of the reasons I love SNS topics is because it allows you to do this kind of email probe where you can subscribe to something and then see if the data that is flowing is the data that you were expecting. One of the nice things, many nice things about topics. Okay, great. But on the flip side, it's going to keep doing it relentlessly until I stop it. So let me terminate this subscription so my inbox doesn't have 1,000 notifications by tomorrow. Okay, so we're good here. We're good here. So we have this guy done. Great. So we have our first module built, deployed. It's doing its thing. It's publishing information on a topic. So what we want to do now is one that basically reads that information.
And just going to let you know that you have 18 minutes till 2 o'clock.
Okay, yeah, excellent. Thank you. So probably then switch over and then maybe look at the code for the remainder of the implementation. So I'll get started this one, and then in order to cover things more efficiently, I'll walk through the code instead. Okay. But as before, we create a new folder called Bitcoin table. So this is the table. The module is going to create a table for storing the prices as we get them. And let's see, /new. Now suddenly I have like Mission Impossible music in the back of my head. I have to hurry.
Sorry.
All good. Thank you. Okay. So here we know that we need also a function. In this case, the function we want is one that a store price function, let's call it. And that's going to be subscribed to an SNS topic 10. Okay, so we have that. And then also we want to add a resource, specifically the Dynamodb table. Let's put a table. Oops. That's correct. Okay, wonderful. Now, Dynamodb tables are something quite interesting, insofar that 90% of your definitions of them will look all have the same starting point. It's not the one that the tool automatically creates because it uses the schema definition to generate an overview of all the fields that exist. But I'm just going to copy it over for simplicity. Although before I do that, I do think it's, yes, you can trust this one. It is kind of neat that when you add it, it just directly points you to the documentation. And from here, you can actually see what all the different fields mean. So it saves a lot of time. But of course, you have to know the type name. Okay, we don't need the description. We don't need the variable. that out. Okay. And the important thing here, well, here I need properties. I'm going to take those in from the module. Oops, module. So this is the part I was referring to that almost always looks exactly the same. Okay, now I grabbed a little bit more. Oh, whoops. I don't think I said the other one was public, was it? No, it was not. Shoot. Okay. I'm just gonna make a change here. I know that sometimes it doesn't like when you just change the export setting. Deploy. We're just going to deploy the other guy again. Otherwise, we can't import it. Okay, so while that's running in the background and updating. Okay. So this is the part. Okay, we need permission to put items in the table. The billing mode for pretty much all small serverless projects, just use pay per request. There is a way that you can pre-provision it, but pay per request is, if you know you don't have high volume, you'll be fine, and that minimizes your cost. Pretty much every table should start this way. And when we talk about DynamoDB in this future session, I'll go into more depth. But you basically have a partition key and a sort key, or a primary key and a secondary key, PK, SK. You always want them, even if you don't need them, you want them. Trust me, just set it up that way. You can't change it afterwards without deleting the table and recreating it. So just always create it. PK, SK, PK is always a hash, SK is also a range. That's your starting point. And then you can add to it. In this case, as I mentioned earlier, we're also adding the definition of a column called expire that will represent our time to live. So in it, we can store Unix time, Unix epoch time in seconds. And then DynamoDB will regularly scan it, and when it scans it and it's past that point, it will do the row on our behalf automatically. Nothing else to do.
Steve,
yep.
On line 10 on here, you don't need that one anymore.
Oh, thank you. Yeah, that would have been compilation error. Probably been a nasty message too, since it's a YAML.
Maybe I should have left it there so you could see the compilation error.
Yeah, no, that freaked me out. All right. So, okay, let's now look at the function that is listening to incoming events. So this is the Bitcoin price notification. So this is what we were publishing earlier. And again, it's an external schema, so it's a little bit more complex. So I guess I just called it Bitcoin notification. So I'm just going to copy it rather than to reinvent it by looking at what's been published. But it's pretty simple. It has, well, I guess we can see it still here if I have. Yep. So what we care about is this Bitcoin price index, and that's a dictionary, has USD, GBP, and Euro. And then in it, what we care about is rate float ultimately, which is the float for the current value. So like I said, BPI is a dictionary of string and Bitcoin quote. Bitcoin quote has I'm just capturing one field, rate float, which is the rate. And then this is what we are, this is the type for what we're listening to and receiving. There you go. And here we need to do the same thing we did before, which is table name. This function only gets called once when things get initialized, function settings. Read. Oh. Please build. Otherwise, we don't get autocomplete, which is annoying. And if I remember correctly, let's see what did I have. Oh, yeah, dictionary and so on. Oh, and then OmniSharp. Let's say start. This will show up in a second. Okay, the other thing we need is NuGet package, AWS SDK, DynamoDB. So we can talk to the database. This guy, latest version, and then store. Yep, restore, please. Now we get a whole bunch of squigglies. Yes. 2. Client. Table. Initialize. Amazon Dynamodb. Statement Amazon Dynamodb client. There we go. Okay. So that gets us mostly there. Then the next step here is basically writing into DynamoDB, and for time of sake, let's just copy the code. It should be good as is with just some addition. Let me, however, walk you through what's going on. So process message async gets invoked by the SNS topic. So we'll create a subscription to the SNS topic, and then our function here gets called every single time the other function publishes. And we want to create a new row in DynamoDB every time we receive it. We set Bitcoin, we set the primary key simply to Bitcoin price, so it's fixed. That allows us to query things later. And then the sort key, or secondary key, prefix time, then pound as a separator, and the current time offset when we received it, plus I fleshed it out to, I think, 12 digits, so it's always consistently. In case we reach a leap, an epoch leap where it goes from 9 to 10, and then suddenly have more digits, and now the sort is wrong. I think that's not going to happen for another 1,000 years, so I'm a little bit over-engineering it here. I'm very optimistic for how long this code is going to run, apparently. Anyway, the next thing we do, we add this expire value to our dictionary of attributes. This weird notation is just something that DynamoDB does. Again, there's easier ways of doing it, but I wanted to stay here close to the metal. We were saying it's a number, and even though it's a number, which sets its type, all values are conveyed as strings. So we take the current timestamp, add 15 minutes, convert it to Unix seconds, epoch seconds, and then that's when we expect Dynamo to delete it for us. Next, we loop over these USD, GBP, and Euro dictionary keys, and we add them as well. We add the rate for them under the key of that. And then this should do it. And lastly, we write it to the database. So, okay, so code-wise, this should be complete. But what we don't have yet is we need to import the topic. So Bitcoin topic, and the module is this guy here. And the name that it exports is topic, right? That was the name of this guy. So this will create, this will, oh yeah, and then we go to type. This is an SNS topic. And, oh yeah, and we need to allow SNS subscribe. Okay, so the Bitcoin topic is coming from this module. That's the resource name inside the module. This is the type of the resource, and that helps us with some type checking. And this is the permissions we need on that resource in order to interact with it. So the next thing we do is here, source, I think it's topic. I'll correct the name, and Bitcoin topic. If not, the compiler will quickly tell us that was utterly wrong, just like it did here. Jason, is that from before still? Oh, must be from before. Ooh, parsing error, line 10. I mess up. Oh, parsing errors are my favorites. Type topic. Okay, line 4. Still line 4. Column 5. I mean, it doesn't like this guy here. No, luckily, we have a version that works. What am I doing wrong? Oh, I don't think it's because I copy pasted from the other guy. I hope not, that it introduced like some characters I didn't like. Bitcoin. Looks the same to me. 910 now. Oh, YAML. What
A mix of tabs and spaces, maybe?
Yeah, do you know how to show the, well, I mean, what I can do is, of course, just do regular expression. No, not tabs. And that's the most common one. Bitcoin table. I think I changed one thing, which was the name of the function, so that I need to keep. Bitcoin topic, table. I think the rest is all the same. Somewhere I had a formatting error, either a gremlin character or, yeah, okay, so Bitcoin function is indeed not in scope, because that's, I forgot. It also shows up here. Okay, there we go. Now I should be back in business.
I missed it. What did you do?
Oh, I copied the original, the one that I know was working.
Gotcha.
Didn't quite use the exact same function names. So that's the part I had to replace. Okay, let's deploy this. But that should be complete. Now, I'll deploy this one, and just for sake of time, I'm going to go and let's look at the code of the third module. Zoom in a little bit here, and that's the activity one. So again, it's not a big module. Similar to what we just did, we are going to import this time the table from our Bitcoin table module. Pardon me. And we're going to give ourselves the permission to query it, because we need it when we record a buy or sell transaction. Pardon me. What is the current price? So we want to kind of record it there. We create a record function, and this one, as source, has API endpoints. So it does a post buy and a post sell. And these are hooked up to individual methods in the Lambda function itself. So rather than to come into a central API gateway proxy kind of request, they are already being mapped automatically when the function starts up, and then it invokes them. We'll take a look at that in a second. And now you see, again, this table definition is virtually identical. It doesn't have the time to live attribute, and that's it. Otherwise, it's identical. And lastly, we print out the URL to make it easy, by making it public. When it gets deployed, it gets shown that way. This guy is still deploying. So let's take a look at the implementation, which itself is also not too terrible. So let's start at the entry point. So we have two methods, the buy method and the sell method. And these were wired up by what you saw earlier, where it said sources, API, post, buy, was then invoke, buy. And that's, let me. Just go back here. It's a little easier than hand waving. What connects the methods is this line. This creates an API gateway with the appropriate resources and definitions to forward everything. And then invoke, it indicates to Lambda Sharp that you want to call this method in the Lambda function that is being defined here. And so that's buy, or buy async. It will automatically look for the async suffix for convention purposes. So we have a method called getLatest Bitcoin price async. Take a look at that. Look at that in a second. And then we get the price, we log it, and then we create a new activity record that has the user ID we received, the current date time offset in UTC, what action it was a buy action, what was the price, and what was the quantity. Quantity and user are provided by the request. And then the sell is identical, except that we use a different string, the sells activity here. get last Bitcoin price. This is where we fetch the information from the table that is managed by the second module we wrote. And that's the Bitcoin price table here. So just as if we had created the table ourselves, Bitcoin price table, we would then say that it's scoped to us, and then we can resolve the name to it just like we would with any parameter that is passed into a function. We also read the table of our own table, the name of our own table, because that's where we store the activity. Then, of course, we initialize the client, same as we did before. And then now this is where, again, working with DynamoDB at this level gets a little tedious, but we issue a query command against Dynamo. We give it the name of the table we want to query against. Remember, we gave ourselves query permission on it. And then the constraint is, hey, primary key needs to match, and secondary key needs to start with the value I'm giving you. We fetch only one record, and we scan in reverse order, meaning we get the last record that was created. The sort key, as the name implies, are sorted. And remember, we store them as time, pound, and then a long integer. If we scan the table in reverse and we take one record, it's the most recent one. So that's exactly what we're doing here. We look at the results of the query, and then we just have a whole bunch of error handling. None are found because maybe this got deployed before it was ready, or there were some other issues. Otherwise, we return. So that's all get latest Bitcoin price does. And then store record async, calls put item async like we saw earlier. But with the primary key now is the user here, the sort key, activity, quantity, and price all being set according to the request. Last thing on the request, because I think this is a lot of fun, is then we return the record that was created. I'll demo that as the last step here in the presentation. Activity request, we're basically saying that the user ID is required and the quantity cannot be lower than epsilon. I should have said 0. I wanted positive, but it can be any max value. Well, I mean, I guess there's actually a finite quantity of Bitcoin, which is why it's technically there should be an upper limit that's probably less than max value. But for our purposes here, that's good enough. So let's go back quickly to the editor. This has deployed, and if the demo gods are gentle with me today, we should have the table here. You can see the resources here. Now remember, this is now subscribed to the topic. So if I go to the table and look at the items, yep, here they are. So this is the code we deployed previously, where the primary key is Bitcoin price, the sort key is the timestamp when it was entered, and then here we have the different values, USD, GBP, Euro, as well as the expiration time when this record will be deleted. Expiration time is not super precise. It can stick around for another 15 minutes after it's supposed to expire, but it will eventually get cleaned up. I've seen it generally hover around 25 to 28 items. Even though we set it a 15-minute expiration, we're going to only get the record once per minute. So it clearly has a little bit of a lag to it. Cool. Okay, so let's do then the last thing, which is just show the API gateway. And luckily I had it deployed earlier, so I'm just going to use that one instead. Activity and outputs, we have our URL. Copy link, go to Postman. So this is the one where we had the API. I just need to set the variable to where we want to post to. We have two commands. We have the buy command and the sell command. The body is pretty simple. User ID 123, quantity 01. So now if I send this, we'll just have to wait for a cold start. But other than that, it should return us activity record. There we go. With the timestamp when it was created, the activity, the quantity, and the most recent price. And because we gave it a limit, if I put in -1, this will actually fail. It will just reject it. And this is not being done by the Lambda. For Lambda, it never sees this. This is actually done by API Gateway because we gave it those constraints. And they have been then embedded into the validation model. Similarly, if we omit the user ID, because we said it was required, this will give us the same thing. So only valid operations, 12 Bitcoins, I wish. Like 10 years ago, it's like, yeah, fuck a change. Now it's like, oh, okie dokie. Great. Oh yeah, then, so if I go here, so this is a much larger module, has some additional resources because of how I deployed it. But this is the table that is underlying the activities. And these are the two buy activities I just showed you, where they got entered. And so now a downstream service could import the table reference and then use it to, tally things or do whatever. Again, it should only do read operations, not write operations. Great. Okie dokie. Where's my presentation slide? Oh, here we go. So to wrap it up. So we covered quite a bit of ground, but you see how all the pieces, how they started fitting together. Oh, one more. We talked about it, but this is important, exports. So we have this topic. If I click on it, it will show that this topic is being used by this table. And if I go to stacks, so I see all my stacks here. This is the topic. If I say on it delete, remember the other stack is using it. This is not going to go far. Update complete. And if you look at the events, it will basically tell us you can't do that. Cannot be deleted as it is in use. So you just locked it down. You have termination protection automatically because of your dependencies. I mean, it's quite nice. And then lastly, the area where the thing that controls that input value is this guy here. This statement tells it to build an input value statement, but if you wanted to, you could actually put in here the ARN of another topic and update the stack, and it would rewire itself to start listening to that topic instead. So again, this gives DevOps the ability of updating topologies and managing code updates that may otherwise be problematic because of the rules that are required. Okay, we're not going to do that. We are going to go back to our presentation and drive this one home. So lots of things I didn't talk about, even though we're like pretty much an hour into it now, a little bit over. Resiliency. So SNS topic here was straight up calling the Lambda function. You should really be going into Cqrs. That said, this one was being called once a minute. So I would say it's maybe not as important, but in general, you don't listen directly to SNS. You have your SNS go to Cqrs, and that just gives you much better resiliency capabilities. And we'll talk about that in a future session. Then, of course, we hadn't had to set any parameters here. Everything was kind of like the defaults were fine. But ultimately, in real systems, you have to configure things, and how do you manage that? Then DynamoDB, we were really close to the bottom. There's some very simple methods that can be used to make life a lot easier. It actually looks like objects that you store, and how you create relationships. And then lastly, we just embedded the functionality straight in place. We didn't give us any room for really testing. Not that there was a whole lot of behavior here to begin with, but ultimately, more complex functions, you would want to do that. So before I wrap it up, the thing, when you combine things together, there's, like I said, there's SNS and EventBridge, and they're incredibly close in functionality. And I'm a big EventBridge fan, and it has really nice use cases. Actually, our Blazor template uses EventBridge for connecting things because of how loosely coupled things are. However, as I pointed out, you really don't know who's then subscribing to your events. It's just not visible. It's these events are just being published into a bus. And then other functions say that they care about certain patterns of these events, and then they get them. And you don't have this tracking like stack export of who is using what in your system. So that's a potential issue. You certainly don't get stack termination. If we'd used a CloudWatch event instead of a topic, I could have deleted the event source. I could have deleted the Lambda function that is basically publishing as an event, and other than not getting the event anymore, you wouldn't have known anything has changed. There would have been no complaints. Cost-wise, they're close enough, and if you have really high volume, maybe. But lastly, and this one is kind of probably the most critical one. Each topic can have up to 12.5 million, 12.5, not 12, not 13, 12.5 million subscriptions. I mean, that's a lot. Compare that to 300 rules, which are what triggers an event, per event bus. Normally, most commonly, you're gonna just use the default event bus. So you're limited to 300 rules. That's it. That's not, that is orders of magnitude apart. So ultimately, which one you should prefer for doing your composition between services depends on a variety of factors. And quite honestly, I don't have yet enough experience with both to confidently recommend when to use one versus the other. It's right now, it's a little bit of a guessing game. But if you have certain limits that are of importance to you, then this might provide some guidance. Okay, so all the sample I showed, as you can see, that the code has been published. It's on our Lambda Sharp GitHub repo, Twitter Lambda Sharp, and that's it.